everybody, I am Jarrett Ross, the Genie Vlogger, and welcome back to another Professional Genealogist Reacts. On today's video, I will be reacting to Haplogroup Map of the World, Your Genetic Surname plus download link from Masaman. Now, Masaman is a channel that I am fairly familiar with. He does a lot of videos about different population groups and races and looks at maps. And I know with my DNA test stuff, I kind of talk a lot about this kind of stuff, but it's really not my focus. My focus is more the actual genealogy part, so how to look at genetic matches and things like that. This has been a really requested video, and I just haven't done it yet because I wasn't sure what I could really say, if anything. Even though I do deal with haplogroups and stuff, it's not like I know about every single haplogroup or anything like that. Like, I know a decent amount about the haplogroup that I'm from. Knowing every single haplogroup is kind of more of a specific type of specialty, whereas my focus is not so much on that kind of stuff. But of course I do deal with haplogroups. So that's all I'm going to say about it for now, but before we do jump into the video, please be sure to give this a like. That really does help me out. Also, be sure to subscribe and click that bell for notifications on future videos. With all that fun stuff said, let's jump into the video.
Is lineage important in the modern day? Some say no, but biology says yes. Some people around the world are quite proud of their lineage, and others not so much, while others say it shouldn't matter at all. Various cultures have different...
And of course, there's us genealogists who are just really, really interested in our history, but one thing I'm always interested in, when I really learned genealogy, was hanging out with my friends and literally being like, what's your ancestry? Because it'd be like, I'm hanging out with you. We are now here in the present in this space, but how did you get here? And so it's kind of that interesting of my family came from here and their family came from there, and you kind of see that history. And it's just, I always thought it was a really intriguing way to, look about everything. So, but let's continue.
Different naming customs passed down from generation to generation in order to preserve their lineage. And this may vary by country. For instance, in the Anglo world, traditionally the father would pass on his surname to his children, but in the Spanish-speaking world, both the mother and father pass on their surnames to their children. Some cultures may traditionally only have one given name, while others may have several, but the surname, or family name, is what is generally passed on to cement the lineage of a certain family. The Kennedy, Clinton, Bush, Roosevelt, and Adams families are all examples of political families in the U.S. that have arguably been successful due to the power of their lineages. There is certainly power in a name. Nature thinks so too. That's why each and every human on the planet has a genetic surname. They're called haplogroups. Haplogroups are...
It's actually a really interesting way to put it, that it's a genetic surname. I mean, technically it's, it's just a classification within a tree. So it's kind of like if you ever look at a family tree that has a whole lot of family members that uses a genealogical numbering system, and you get to the more recent generations, they'll have these crazy numbers just because there's so many generations before that. And that's kind of what you get with haplogroups, is every time you have a newfound haplogroup, then that's a sub of a previous haplogroup usually, and then you have a whole new branch that's then defined differently. So that's probably what he's about to explain. I probably explained it really terribly there.
Are genetic markers that are extremely important in the study of history and anthropology because they can show an individual's or collective's simplified genetic past that gives clues to how different populations interacted. I've explained this in a past video, but essentially a woman will pass down her mitochondrial or maternal haplogroup onto all of her children, while a man will only pass down his Y-DNA or paternal haplogroup only to his sons, because only males have a Y chromosome. Your maternal haplogroup is passed down from your biological mother to you, and it was passed down to her by her mother, your maternal grandmother, and your grandma's mom, and so on and so on. Since only males have a Y chromosome, if you were male, your father passed his paternal haplogroup to you, passed down by his father and his father before him. For tens of thousands of years, these haplogroups have been spreading across the globe, splintering and diversifying due to genetic mutation between generations, and this paints a very interesting picture. This is a pretty awesome map showing paternal haplogroup distribution around the world, but I think it could use a bit more detail and modernization, so I'll be attempting to remake it to the best of my ability.
Now, I don't know if this is something that he's going to discuss, but one of the really interesting things that I find about Y chromosome genetics and like studying the haplogroups is that because there's kind of a rate of genetic mutation, I think it's basically 1 out of every 5 births there's a genetic mutation about in the Y chromosome, which then means that's a new haplogroup. And because of this, we can actually figure out when there were times of prosperity, because what we'll find is in a short amount of time there will be a wider variety of new haplogroups. And why this means that there's prosperity is it means that there's a lot of births. So the rate is for 1 out of every about 5 new births of a male, there will be a mutation on the Y chromosome. Well, if there's not that many males being born every generation, basically it's really hard to have a family and have males survive where they then have a living lineage. Then that means that there's going to be less diversity because there's going to be less births. And just by statistics, that means less births. 1/5 of those fewer births means there's going to be fewer mutations. So when you look at these haplogroups and you can find a period of a whole bunch of mutations, it can actually tell us a lot about how prosperous those civilizations or those people were. So that's something that I just always found really interesting about it, where, you know, they can actually look and figure out general time periods based on when that big diversity of haplogroups happens, and then figure out within that time period kind of what was going on in correlation to that big prosperous, big amount of mutations happening, aka a whole lot of births happening because life is going pretty good at that point. All right, let's continue.
Let's start with arguably 2 of the world's oldest paternal haplogroups, haplogroup A and B, which branched off around 150 and 100,000 years ago in Africa. And these are distributed mainly among the most ancient gene pools of all of humanity, the Pygmies, Khoisan, and Nilo-Saharan speakers of the continent. And for context, here's what it looks like with modern-day borders. These 2 haplogroups are present in much smaller amounts throughout Africa, but were formerly dominant throughout sub-equatorial Africa before the migration of the Bantus from West Africa, with whom they had limited intermixing over thousands of years. Niger-Congo speakers actually mostly belong to haplogroup E, specifically EM2, formerly known as E1b or E3a, which has spread out to become dominant in most of sub-Saharan Africa, including Madagascar, where the population is mixed between Bantus and Austronesians. The descendants from the transatlantic slave trade in the Americas have also carried this haplogroup into the Caribbean, the southern U.S., Central American countries like Belize, Nicaragua, and Panama, as well as in the Guyanas and part of northeast Brazil, which is the country with the largest number of people of full or partial African descent outside of Africa itself. Around 8 to 10% of the male population globally belongs to this haplogroup. Another haplogroup belonging to the E branch, EM215, formerly known as E3b, is highly associated with speakers of the Afro-Asiatic languages in Africa, meaning it is predominant in Ethiopia, Somalia, Eritrea, parts of Sudan and Egypt, and nearly the entirety of the Maghreb, and is also present in the Middle East and Southern Europe, especially in the Balkans, where it reaches rates of around 15 to 30% for Greece, Albania, Bulgaria, and Romania. Jewish descendants are also heavily associated with EM215 in Europe, which makes sense considering they originated in the southern Levant near Egypt, and it's even been suggested that a certain genocidal 20th century dictator with a funny mustache belonged to this haplogroup, which is truly ironic. Greece has one of the most diversified haplogroup distributions of any area in Europe, which reflects its unique role in ancient European and Middle Eastern civilizations, as Greeks were formerly spread out across the entire Mediterranean, and in the present day, around 20% of Greece's population is descended from Greek refugees from the Ottoman Empire, while around 5% are descended from refugees from the Soviet Union.
And I notice a whole lot of J2s, which I'm actually, I'm a J2. My subhaplogroup is from J2, which actually, so this is actually my haplogroup right here. And that's, I think that's me. Yeah, that's mine. So this is basically where I come from. You can see it goes to J2 right there. So, and then it all goes up root chromosomal atom. So, but you can kind of go back. It's cool. You can go back and then see. So each one of these is a different haplogroup, and it's basically a family tree where, there's these three different groups coming off of this one, but then when you look at this, it's broken down even further. And over here, you get that information about, about where that shared ancestry is. So I believe TMRCA stands for time to most recent common ancestor, or something like that. So basically, this other person and I, we had a recent common ancestor, likely sometime who lived between 500 to 1600 years before present. So just a little interesting aside.
When it comes to Europe, the oldest haplogroup in the continent is actually Haplogroup I, divided between I1 in the north, mostly in Scandinavia, and I2 in the south, mostly in the Balkans and Sardinia. And due to immigration to the Americas, Haplogroup I is also found in high numbers in their descendants in the US and Canada, and is also found in northern Russia around Arkhangelsk due to the strong Norse influence on the Pomors, a subgroup of Russians in the far north. This haplogroup actually predates the Indo-European expansion and is believed to have branched off from its closest relative, Haplogroup J, around 40,000 years ago. Haplogroup J is divided between two subclades, J1 in the south, primarily in the Arabian Peninsula and parts of North Africa, and J2 in the northern Middle East and parts of the Mediterranean. Outside of Arabia, J1 is especially present in males from Sudan, despite being significantly mixed with Nilo-Saharans and Afro-Asiatics, possibly due to the mass migration from the Arabian Peninsula into Sudan after the 16th century. J2 is present in smaller numbers in Caucasian ethnic groups like the Chechens, as well as in South and Central Asia, showing previous migrations to these regions. The only other place J is common is in South America due to the large number of descendants from southern Italy and the Levant. This is where the fun begins, as now we'll be looking at haplogroup R1.
This one is a really interesting one. This one's really common as well among many Jews. It's usually like R1B1, I forgot exactly what it is, but I think that's actually one of the most common haplogroups in the world, as you can very well see by this map, and I'm sure exactly what he's going to explain. As I said in the beginning, I don't know, a whole lot about, every single haplogroup. I only know bits about a few, and this is one of the ones that I am a bit familiar with, because I have dealt with a few different people's Y-DNA results that had a R1B descendant, or they were part of that tree,
which originated in North Central Asia around 20,000 years ago. This haplogroup is widely associated with the spread of Proto-Indo-Europeans from their heartland in the Caspian Basin, with R1b being predominant in most Western European ethnic groups from the Germans, Italians, French, Iberians, and inhabitants of the British Isles. R1a is spread throughout most of Eastern Europe, except for the Balkans, and has a moderate presence in Eastern Germany and Austria, showing the large degree of admixture between Slavic and Germanic peoples in the region, and is quite rare west of the Elbe River, except for a large number descended from Polish migrants near Köln. But when we look at the rest of Eurasia, we can see that R1a spread to areas of southern Central Asia among the Kyrgyz, Uzbek, and Uyghurs, but most notably to South Asia, where it is dominant in much of the Indo-Aryan population of northern India. But what's truly astounding is when you look at the spread of haplogroup R1b, which is scattered throughout the Old World, especially among the Armenians and Bashkirs of Russia, but also among the Chadic-speaking groups in West Africa. But these did not result from European colonization, but rather by previous migrations from the Middle East or Central Asia, where R1b can be found in smaller percentages. R1b was spread by European colonization to the Americas and Oceania, and even in highly mixed Latin American countries like Brazil, R1b remains dominant at over 50% of the population, an even higher percentage than in the United States. And this is believed to be due not only to post-independent European migration, but also due to the initial Portuguese settler population. In the Americas, haplogroup Q is dominant among the vast majority of indigenous peoples, and due to intermixing with Europeans, Africans, and others over the centuries, is present in varying amounts in most Latin American countries today, with the exception of the Caribbean. Haplogroup Q is also scattered throughout North and Central Asia, notably among some Siberian groups like the Tuvans, as well as in Turkmenistan. In Central Asia, haplogroup C has spread to various areas due to the migration of Mongolic and Turkic tribes nearly 1,000 years ago, and is now dominant among the Kazakhs, Hazara, Mongols, and various populations in Siberia and the far northeast corner of Eurasia, as well as among some Native Americans in the far north of the Americas, and most shockingly is also dominant among some populations in Oceania, such as the Moluccans, Australian Aborigines, and Polynesians. Let's take a look at the far north of the Eurasian landmass, and this is actually made up mostly of haplogroup N, believed to have split from haplogroup O 30 to 40,000 years ago in Northeast Asia, and spread west to various groups in Siberia, the Ural region, northern Russia, Finland, and even the Baltics. Interestingly, haplogroup N is also found in much smaller numbers in southern China and Vietnam, showing its eastern origins. When it comes to haplogroup O, it gets a little confusing as the map shows 4 subclades. O-M119, which originated in southern China and spread through much of insular Southeast Asia due to the expansion of the Austronesians, and is found in its highest numbers among the Taiwanese Aboriginals, the Philippines, Borneo, Sumatra, as well as in Madagascar. OM268 likely originated in southern China or northern Southeast Asia, and this is kind of a weird one because it's really spread out all over the place, with the southern branch being spread by Austroasiatic speakers and hence is common in Vietnam, Cambodia, and the Austroasiatic speakers of eastern India, as well as in insular Southeast Asia due to previous Austroasiatic migrations there in the past, while its northern branch is located primarily in Korea and Japan. Haplogroup OM112 originated in China and is to date most heavily associated with Thai, Hmong, and Sino-Tibetan peoples, but is also spread throughout much of mainland and insular Southeast Asia. Haplogroup H, which was formed around 50,000 years ago, is today present in its highest numbers mainly in the southern and eastern portions of the Indian subcontinent, although it is present in smaller numbers throughout South Asia as well as in scattered pockets throughout Southeast Asia, Southwest Asia, and Central Asia. Because I'm running out of time, here are the other haplogroups that were chosen to be depicted on this map, like T, which is kind of scattered all over the place, L, located mostly in South Asia, D, which is a unique case being spread out among Tibeto-Burman, Japanese, and Andamanese populations, as well as K, M, and S, which are present among the indigenous peoples of the Philippines before the mass Asian migration, like the Aeta, and among Melanesian and Micronesian populations. Here's the finished product, and I must admit, I am kind of curious as to why no one's ever done this before, and it's up to your boy, the internet weirdo with the failing liver. But I think this project turned out pretty well, and does a good job showing the distribution of various haplogroups around the world. Is anyone actually interested in this? I don't know. But I had fun making it and doing the research, so feel free to check the download link in the description to grab the map for yourself and mess around with it. Again, I'm not an expert by any means, and this map doesn't show all paternal haplogroups in the world, of course, and it doesn't quite have as much detail as I would like, but I'll be working hard to improve it in the future as I continue to learn. If you've ever taken a genetic test and know your paternal haplogroup, share your thoughts about my map and how I could improve on it in the comments down below. Thank you all so much for watching. As always, this has been Mason. I'll see you next time.
All right, well, that was a really interesting video. I didn't really have much to say on it. I'm sure a lot of people noticed because, it's a lot of interesting stuff, but it's just not, super important to genealogical research. It certainly can be useful for genealogy in some cases, especially when you're dealing with unknown parental ancestry, especially with an NPE, non-parental event, or an MPE, misattributed parental event. There's a few different names for it, but basically, maybe you're someone where you don't really know your paternal ancestry and you're not quite sure where you're from, and then you take a Y-DNA test or you take a test that gives you your haplogroup, and then your haplogroup is something that you really weren't expecting. Like maybe you come from, you think you come from an almost European ancestry, but then all of a sudden you get a haplogroup that's one of the ones that's really directly tied to South India or South Asia or something like that. And then it's like, okay, well, that means that if I trace up the paternal ancestry, eventually I'm going to find an ancestor who was likely living in India or in the areas where that's very common. So this map is really, really interesting. I feel like there may be some flaws in it just with that fact of this is really more of a map of where are you going to find people with that haplogroup than the kind of ancestral location of those people. Although I think that's kind of tied into this in a way, but it also kind of ties in of the common ancestral migration patterns of these different people. But I think one of the other things that is probably difficult in showing something like this type of map is you're going to have a lot of areas that are going to cover each other. And so it's a question of, well, how are you going to represent that when, like in South America and North America, you have all of these different colors, like you have that purple popping out, but a lot of those areas that have that purple, we know that there's also those same areas that have a lot of the dark blue, whatever that haplogroup was. I can't remember. I think that was the R1b. So in a way, it is giving an idea, but then it's also a little confusing because some areas that might have a good representation of one of the haplogroups, you can't tell as well just because it's being covered by one of the other haplogroups, which is probably why you haven't seen anyone make a map like this, because you're going to run into that issue of, well, what are you going to do when you have those overlaps? Because if you then lighten it up or make it opaque to show the other one, you're technically changing the colors, and then it's going to be even harder to read. I feel like a map like this might be better where you're using colors, but maybe you're also using colors with dotted lines. So then you can kind of see where the dotted lines are overlapping each other, maybe. I don't know. I'm certainly no map maker. So again, certainly a very interesting video. If you are someone that's looking to use Y-DNA to figure out your ancestry, focusing on just your haplogroup isn't really the best idea. And I do hear people say all the time, well, you don't need to take one of the in-depth family tree DNA Y haplogroup tests because 23andMe, you can just test with them and they'll give you your autosomal DNA and they'll give you your Y haplogroup. Well, the big difference between 23andMe and Family Tree DNA is 23andMe just gives you the haplogroup, which isn't really genealogically useful. So it can give you maybe a hint on genealogy stuff if it goes against like what you know of your family. Like I mentioned before, you think you have all European ancestry, then all of a sudden you have a haplogroup that's very, very common among people that aren't European. But most of the time, people are just going to get a haplogroup on 23andMe that's just like, oh, okay, well, somewhere in this big map of places. So like if you're R1b or something, you're really not going to get that best of an idea because it's going to cover a ton of the world. But when you test on family tree DNA, or if you're able to take a different test that you can upload to something like YFull that has enough data where you can do genetic matching, that's when you can actually use Y-DNA to do genealogical research, because when you find matches, you know that you're at least going to be related up your paternal line. So you trace up your father's father's line and their father's father's line, and you're going to find a common ancestor. So you know exactly where to trace in the family trees. It just becomes a question of how far back. And depending on which test you go with, because there's different levels of Y-DNA testing, you can get better and better ideas of how far back that can be. So sometimes you might get matches where your most recent common ancestor might have lived a couple of thousand years ago, but then you get other matches where your most recent ancestor might have lived 300 to 500 years ago. And for a lot of different people, that's actually genealogically relevant, and you may actually be able to figure something out from it, because 300 to 500 years ago is, 1700s to 1500s, and I have my family tree traced back that far. Not on my Y lineage, though, unfortunately. My Y lineage is only traced to the early 1800s. But still, you can kind of get an idea of what the big difference is, where if you do that 23andMe, haplogroups really only going to give you an idea of like the past 6,000 years. But then when you do one of the more in-depth family tree DNA tests, you're going to get a better idea, especially with your matches, to the past, 1,000 or 2,000 years. But when it comes to using Y-DNA for your genetic matching, it's really going to matter on what genetic matches you get. And so it's just luck of the draw of how many of your Y chromosome relatives have done a Y-DNA test. And unfortunately, not a whole lot of people have done the in-depth Y-DNA tests, so that basically means that there's going to be a higher chance that you're not going to get any genealogically relevant genetic matches on your Y chromosome test. But back in the day, it used to be the same thing for these autosomal DNA tests, and I remember people back in 2015, 2016, always telling people, just wait, there's going to be more people testing and testing. And over the years, all these people that used to say, I don't have any good matches, all of a sudden have tons and tons of good matches because more and more people are testing as time goes on. So hopefully more people will do Y chromosome testing. And as that increases, these Y chromosome tests on family tree DNA are going to be much more viable to actually figure out your family ancestry. Now, at one point in the video, I mentioned really quickly the idea of Y chromosome atom. Basically, if you trace back every single haplogroup, you're eventually going to find one common ancestor that everyone in the world descends from through their Y chromosome. And that person is known as Y chromosomal atom. And if you'd like to know more about that concept, be sure to check out this video here where I discuss that in more detail. And if you enjoyed this video, please be sure to give it a thumbs up. That really does help me out. You can also click right about here if you'd like to subscribe. It is completely free to do so. And you can also follow me on Facebook, Twitter, or Instagram at GenieVlogger. I'm the Genie Vlogger. See you in my next video.